start gearing up for finals. So that's exciting, hey? Ooh. All right, so what was that, Cindy? I thought you said, oh. I thought you did say something.
Oh, I don't think so.
Okay. .5 infinite geometric series. So we learned about geometric series the other day, right? That's when you're taking a block of numbers in a geometric sequence and just adding them together. So, you know, like a geometric series looks like this: 2, 4, 6. And then let's say we got a number here, 1024. We could add up all those terms and find out what the sum is, right? We could find the sum of this series. Sometimes, though, a geometric series goes on forever. All right? And then it's infinite. Okay? So, for example, so what we're trying to do there is calculate some terms. So let's say we had a geometric series like this. Four, 2, 1, 1.5, 0.25. See how the numbers are gradually getting smaller? That's because my R value, if I did R equals T2 divided by T1, that's going to put it at 2/4. Aha. So what's happening here, oh, this just keeps going on forever. What's going to happen here is because these numbers are getting smaller and smaller and smaller and smaller and smaller, they're going to slowly work their way down to 0. But not exactly 0. They're going to come very, very close, but never exactly 0. You're just going to keep getting very small decimal numbers. So what that means is you can add up all these terms. So these numbers will continue to get smaller and smaller. So that means we can find the sum of the terms. Sorry, the sum of the series. Okay. This is known as a convergent series. This is a convergent infinite series. And what that means is R, oh, wrong way. That is true. R is less than 1. Okay? But it also means it's greater than -1. This is like the golden rule.
Okay, it's not a 1.
This?
Like,
Oh, that one? Yeah. I don't know why I did 2 styles of 1.
Okay.
Horribly inconsistent. Let's fix that. This is very important. You have to be able to know if your R value is between -1 and 1. Okay, I'm assuming you guys are going to be okay with that. It's harder than it sounds actually with this stuff. This throws a lot of people off. Okay? Now, if your R value, let's say, is bigger than 1 or less than -1, like let's go -2, oh, holy cow, hold on, -2, 4, -8. This one, my R value now is -2, right? That's less than -1. So what that means is these numbers are going to keep getting bigger and bigger and bigger and bigger and bigger. So if they keep going on forever and they keep getting bigger, can we eventually ever add them all up? No. So this series just goes on forever. Okay? It goes away from the beginning. This is known as a diverging series.
okay, how do you know that it's divergent?
I check the R value. It's not. Right, it's not in between -1 and 1. So R is now less than -1. So the infinite series will go on forever. Forever is one word, I messed up. But I caught my own mistake. Will go on forever.
Right, you're not an English teacher.
That means there is no sum. Okay, you can't add them up because it keeps getting bigger and bigger. That's the thing about infinity. It keeps going on and on and on and on and on and on and on forever. Every time you come up with a really big number, you just add 1 to it and keep going. But infinity, with numbers getting bigger and bigger and bigger like that, as soon as you make them a fraction and put it 1 over that number, they get smaller and smaller and smaller and smaller. And they go towards 0. Okay, that's why if your R value is between -1 and 1, those values just keep getting smaller and smaller and smaller and smaller.
Of course, they still get to a point where they're like in the realm of like a feasible number because
They're so small.
they're so close to 0, it's basically nothing.
Well, like you're adding, like decimal places, you go from the tenths, hundreds, thousands, all of a sudden you're in the billions,
Yeah.
trillions, right? It just keeps going on and on and on.
Yeah.
So yeah, like your decimal value keeps growing, but it's so far away from what the actual number is that it's minuscule. Okay? When this happens, it's known as a diverging series. Okay? So there's nothing to be done. If a series is diverging, you can't do anything with it. Any questions between diverging and converging?
Diverging would also be like if R is greater than 1.
Right, absolutely. It can be a positive value bigger than 1 as well. Okay? So like if your R value is 3, it's divergent. You're done. Okay? Determining the difference between converging and diverging is the hardest thing here. Okay?
Easy.
So if it's diverging, there's no sum. So now, to find the sum of a converging series,
I'm here.
right on. Good to see you.
Thanks.
I don't think anyone else is, like kid-wise, but no. Okay. I don't know
So, he really didn't want to.
if
So I bet.
yeah, the stars align for him there.
Yeah.
Okay, so to find the sum of a converging not infinite, infinite series, use this. Super simple formula. So we use an S again for series and sum. But this time, instead of like the nth term, because it's infinite, the terms don't stop. So we use this cool little. You guys all know what that figure 8 stands for?
Yeah.
Excellent. Stands for sideways 8s, right, Dean?
Yeah.
That was like a solid dad joke there. All right. So it's just T1. I'm not going to explain what T1 is anymore. If I have to, just put your head down and go to sleep. I shouldn't have done that. That was too easy, Levi. Divided by 1 minus R. And that's it.
Yeah.
That's it. And remember,
And I hope for T2, maybe like if I have to explain T2, then I'd start like I'd say like the description of Terminator 2.
So
I made that joke like so many times.
you've really driven that one to the ground, Sam.
I know, right?
You are unrelenting with your TQ jokes, but it's good.
What other time and math will I be able to do that?
Do you guys even know what Terminator 2 is? The movie's like way older than you guys.
I've never actually seen that. I just know it's called T2, and I was like, haha, funny.
It was like one of the biggest movies of the 90s. It was huge. Arnie? It was good. It's a good movie. Arnold Schwarzenegger.
Wow.
Former governor of California. Predator. Twins.
Twins, movie
Wait, you're talking.
Trying to think of other Arnold movies
My
now.
dad just like watches old movies whenever they come on TV, so I've seen like bits and pieces of a lot of them.
Twins is a great movie. What was the one where he's on Mars? Oh
my god, there's one where he's on Mars.
yeah, Colin Farrell made the remake of it. Holy cow! All am I missing that one now? Not The Martian. Say it again.
Mars Man.
Not Mars, man. Total Recall. Holy cow!
He's on Mars and
Oh yeah, he goes to Mars. Yeah. Frees the people of Mars. That's great. Yeah.
that sounds like a good film.
Right?
Yeah.
That's why I got elected governor of California, because he freed the Mars population.
Two.
There's still like a big part.
Mr. Weber, this has to be the last example. You guys are going to run out of paper.
Okay. Don't worry. Yeah, this lesson isn't that hard. Find the sums of the following infinite series. So let's do the first one.
So, like,
I'm lost in it.
So,
So,
Where's the S infinity?
what's here?
Oh, wait.
First thing you do, if I say find the sum of an infinite series, what do you think you got to check? Very good. Let's check R first. So R is just going to be negative 1/3 divided by 1. Anything divided by 1 is just its sum. So is R between negative 1 and 1? Yes, it is. Did you say yeah? I can never tell. I can't read lips or faces anymore, so it's hard with the math. But yes, of course. So we're good. So this is a converging series, so we can find the sum of it. So sideways 8. T1 is 1. 1 minus 1, right? Yeah. 1 minus negative 1/3.
Wait, that's the first value?
1 is, yeah.
So that not just 1 plus 1/3.
Very good. Do I need to show how to add up the fractions?
Oh, yeah.
1 would be written as 3/3. I'll do that over here. So
I'm very good at fractions.
4/3, correct? So I'll show this once with the fraction just because you might see it. 1 divided by 4/3 looks like this. What's the rule for dividing fractions?
I don't
Reciprocal. Yeah. You flip and multiply.
Oh, okay.
You multiply by the reciprocal.
Oh, wait, I already got that.
Let's scroll up with the teeniest bit.
Yeah, sure, sorry. Okay. That's your answer.
Oh, yeah, that's what I got. Okay.
Okay? So that means these numbers are going to keep alternating between negative and positive, but they're going to get smaller and smaller and smaller and smaller. But if you just add them all up, they add up to 3/4.
How come it becomes from 1 subtract negative 1/3 to 1 plus?
When you subtract a negative number, it becomes positive. Yeah. Cool? Let's do one more. Levi's like writing on the very bottom corner of his page. Don't worry, this one won't take a lot. The next example, let's go 4, 8. What's the first thing you do with an infinite series?
You check the R value.
Check the R value.
I was right.
Okay, my R value is 2, so what do?
Nothing.
Bingo. It's divergent. Divergent. So it's done.
Even if you make all your points on flat.
Okay, questions? Pretty straightforward, hey? Okay, page 63. 1/7. That's it. That's math. Free calculus.
That's the last thing.
This is the last thing.
Isn't there a whole other unit after this? And I like,
No, that's it. We gone through 1 to 9.
I think we did 9 yet. We did 9? Oh, 9.
9 was the first thing we did when I got back.